Okay, so here we're going to get started off with question 6, as previously stated. So, as continuation, it first says the diagram below shows the graphs of f of x, which is minus x minus 3 all to the power 2 plus 25, and g of x, which is supposed to be 2 to 1 over 2 to the power x plus 1. So it's supposed to be x plus 1 in this case. Sorry, x plus 1 minus 4. Okay, so basically that's the question that we are faced with. We have a parabolic function of f, and we have a exponential function of g, right? And that exponential function is all raised to the power x plus 1, right? X plus 1 minus 4. And then the question basically also gives us information about f, that there's point A and C on it. There is also E, which is the y-intercept, and then there's also D, which is a turning point. And then they also tell us that graph G cuts the x-axis at A and the y-axis at B, right? There's B and A. And then the first question basically asks us and says, okay, 6.1, write down the equation of the asymptotes of G. So we need to write down the equation of the asymptotes of G. Now, automatically, the asymptote you actually find from the formula of the exponential function. So g of x is equals to 2 with the base of half, all raised to x plus 1 minus 4, and therefore then our asymptote in this case would be y is equals to minus 4. Okay, so it's just y is equals to minus 4. Then the next one says 6.2 says write down the coordinates of D, right? Now when we're looking for the coordinates of D, this has to do with the turning point. D is the turning point of the parabolic function. But what do we know about parabolic functions and their formulas? We know that when the parabolic function, if it was in a quadratic form where it says a of x plus b plus c, right? If it was in the form a x square plus bx plus c, when we complete the equation or the quadratic formula, we find that it would give us a form of this nature. But this form actually tells us everything we need to know about the turning point, being that this has to be 3 maps 25. So D is 3 maps 25. How do we see that? So x minus 3, you'd equate it to 0. That would give you just 3. But also remember, it's also a shift. If it shifts to the right, it's a minus. But if it shifts to the left, it's a positive, right? So then you have to take it oppositely, so, and then make it opposite. So it's 3 maps 25, right? So it's 3 maps 25 for D, so it's just 3 maps 25. Okay, and that we got from the equation. And then the next question says write down the range of f. So we need to write down the range of f. Now the range of f is quite easily found, right? The range of f, a range is talking about all the y values. So what are all the y values that we find for f? In this case, obviously here at 25, right? This is the highest or maximum point, right? Because other than that, this is the turning point. Once it just turns back down, and it would never go above 25. So in actual fact, then it is y that is less than or equals to 25, right? And it includes 25 as part of the range. Or you could have written it as an interval notation where you said it's y, which is an element of negative infinity to 25, right? So, and this is a closed bracket because it is included. This is an open bracket because it is not included. Okay, and then we have it says calculate the length of ED. Now where is ED? There is E and D, right? But notice something, E is on the y-axis and B is on the y-axis. Therefore the distance of EB, right, the distance of EB, so this is 6.4, So if you notice, the distance of EB is supposed to be equals to the function of function f of the parabola. Why do I start with f? Because it's at the top, right? So it's going to be whatever the value is for the y intercept coordinate subtracted by the b intercept coordinate of the g function, right? So basically, but how do we get that y is supposed to be a y-intercept? We make x to be 0, so then we say it's f of 0 minus g of 0, right? Now, if it's f of 0, g of 0 give us eb, then it's quite clear what to do. We just need to use the formula. So the formula itself says it is minus x. Okay, sorry. So it's minus 0. It's minus it's minus 0 in the bracket minus 3 squared plus 25. Okay, that's a bracket there, and then it's all subtracted by 2 of half of 0 in the place of x, right? Because we made x to be 0 minus 4. Okay, and when you do this on your calculator, you'd actually find that the answer here would be 19, right? So EB will be 19 units, right? 19 units, because it's length. So it's 19 units. Okay, so it's 19 units, and basically that's how we found that value. Okay, and now we move on to the next question, which is 6.5. So let me actually move this closer up. So let's move this back up. So move it back up. Back. There we go. This is way better, so that we don't have to scroll too much. So now 6.5 says determine the values of x for which f is decreasing. Now we need to determine the values of x where it is decreasing. And what does it mean when it's decreasing? It means that it's for all the values where when your x is increasing, right? When your x values are getting bigger, your y values are getting smaller, or vice versa, right? So basically, what would that mean? We are looking for a point on f, where the x would be increasing, but then the y would be decreasing. So if we look at it here, from the turning point here, which is at point 3, right? Going that way, x is increasing, but going from here on this side of the function of f, it's decreasing. So that means it's a decreasing function. Henceforth, that would mean what? The values that would be decreasing would be from 3 going to infinity. From 3 to infinity. But when you think of it, do we include 3? No, we don't include 3, because this is a turning point. And at a turning point, there's no increase or decrease. So hence, we say it is x that is greater than, when x is greater than 3, then we would find that obviously we would have a decreasing function of f. And then we can also write it in interval notation, where you would say it's an open brackets for 3, because we're not including it, and also for infinity, because we don't know what the value of infinity is. And then 6.6 says calculate the average gradient between points A and B, right? Now the average gradient between point A and B. Now point A is what exactly? It's actually the x-intercept of g of x, right? And then point B is actually the y-intercept of B. So we already have this one in a way that if we looked at this one here, where we got the y-intercept for g, the y-intercept for g in this case, if you calculate it, it would have been 2. Okay, so this is going to be half times 2, which is just 1, minus 3, minus 4, sorry, that would give us minus 3. So we know that in actual fact, for point B, it's supposed to be maps 3, maps 0. So we have that point, but now we need to find the average gradient. But a gradient, when you calculate it, remember an average gradient, so an average gradient, so an average gradient would be equals to what exactly? Would be equals to y2 minus y1 all over x2 minus x1, right? So that's the way that we could do it, right? That's where we need to get to. However, we need another point. So for point B, we do have it. So we could imagine that y2 here and x2, or x of b and y of b we have, but now we need y of a and a x of a. Luckily, we do know one thing from this, is that obviously since a is on top of the x-axis, that would mean x of a is equals to 0. Okay, so basically then the first thing we just need to do is that we need to make y to be equals to 0. So firstly, so 6.6 there, so 6.6 in black. So then we say we have g of x, right, which is equals to 2 of 1 over 2 of x plus 1 minus 4. And now basically we would let, right, because at point A it's x-intercept, so we would let g of x to be equals to 0, such that 0 is equals to 2 times 1 over 2 of x plus 1 minus 4. And then we would simplify that obviously to solve for the value, and we would actually find that this is 2, and then this is 1 over 2 all raised to the power x plus 1. But luckily 1 over 2 can be rewritten as 2 to the power negative 1, or multiplying x plus 1, right, like that. And we have 2 all to the power 1, and then we just bring down everything. So once we bring down everything, we actually find that it will be minus x minus 1 is equals to 1. And remember where this 1 comes from. This 1 comes from this exponent, and this minus x minus 1 comes from there, right? So that's quite clear. Now then we just solve for x, and solving for x in this case is quite straightforward. So x would be equals to negative 2. Therefore, for a, we know now it is negative 2 map 0, and for b, we know from previously it's minus 3 maps 0, right? Sorry, not minus 3 maps 0, but 0 maps minus 3, right? So it's 0 that maps minus 3 because it's the y-intercept. But then we need the average gradient, right? So the average gradient in this case, then it would be the y of b minus the y of a, right, all over the y of b, the x of b, minus the x of a. And so we already know what the y of b is, that's minus 3. The y of a is 0. We know now for the x of b, that is 0. And then the x of a is minus 2. And so from there, we actually find that this is supposed to be minus 3 over 2. So the average gradient in this case is minus 3 over 2. So the average gradient is minus 3 over 2. Okay.